Hi students, myself Professor Ramappa, Assistant Professor in Physics, Government State College, Navanagar, Bagalkot, affiliated to Rani Chennamma University, Belagavi. Your first year physics syllabus contains four chapters. The first one is conservation laws, second is gravitations. Inside that you are having a rigid body dynamics. The third unit is elasticity. The fourth chapter is theory of relativity. These are the chapters included in your first semester of physics lab. Here, we will discuss about the first chapter, that is conservation law. This conservation laws contains 15 hours syllabus. Inside this, you are having law of conservation of linear momentum, collision process, elastic and inelastic collisions, law of conservation of linear momentum in case of variable mass, that is in rocket, and torque, angular momentum, law of conservation of angular momentum. The next important concept in this chapter is law of conservation of energy, work energy principles. These are the syllabus included in your first chapter. Let us start. The beginning of this chapter is law of conservation of linear momentum. In this session, we will discuss about the law of conservation of linear momentum, center of mass, expression for position vector, velocity, acceleration, and force of center of mass. So these things we will be discuss in this session. Okay. You know that already you have learned in your previous class regarding momentum. Then you are observing the faster moving object. It is difficult to stop the faster moving object as compared to the slower one. So in order to stop the faster moving object, you need what? A large amount of force as compared to the slower one. That means the amount of force applied on the object is depends on the what? The mass of that object as well as its velocity. So here the quantity of motions possessed by the object is termed as a quantity called as momentum. So the momentum is measured by the product of mass of the body and velocity of that object. And it is given by P is equals to m into v. The term momentum is designated by a symbol of P, that's equals to m into v. And the SI unit is kg meter per second, and it is in a vector a quantity. Okay. So next to then what's the meaning of conservation? Conservation means some physical quantity remains constant. So the something is remains constant. And vector, you know that the quantity, the physical quantity, it is having both magnitude and direction. Next, you know the term velocity as well as acceleration and force. Velocity is nothing but the rate of change of what? Displacement with respect to time. Simply you can call it the what? The change in displacement with respect to time is called as velocity. And acceleration is the rate of change of what? Velocity is called acceleration. Uh, uh, push or pull is nothing but your what? Force. Okay. So these things already you are learned in our previous class. So the first concept mentioned in your syllabus is law of conservation of linear momentum. How that linear momentum remains constant, that we want to discuss. For that, consider a system having n number of particles. Suppose if that system is having n two particles, the total linear momentum of that system remains constant only when if there is no external force acting on that system. In such cases, the linear momentum of that system remains constant even though the linear momentum of that individual particle may change due to the interactions between them. Whatever the change in linear momentum of the any particle is exactly equals to the change in what the linear momentum of another particle, so that the net momentum or the total momentum of that system remains constant. Okay, so this is about what law of conservation of linear momentum. You can state that the linear momentum in another way. The momentum neither be created nor destroyed. What it is? The momentum neither be created nor be destroyed. That is, if two bodies collide one another, the momentum before collision is equals to the momentum after collision, so that the total momentum remains constant. Whatever the total momentum of the system is there, that remains constant. Okay. So for that, you consider one system having its total mass capital M, and V is velocity of that system, but here I am designating by symbol of VCM, that's velocity of center of mass. So when you differentiate that above quantity, you will get dt by dt equals to m into dvcm divided by dt. So dvcm divided by dt is nothing but what? As the acceleration, that's what designated by acm, which is m into a is nothing but what? Force. So then the above quantity becomes what? dt by dt equals to f external. So our statement is, in the absence of any external force acting on that system, the total linear momentum of that system remains constant. So according to that statement, if external is equal to 0, then dt by dt is equal to what? 0. That means change in momentum with respect to time becomes what? 0. It becomes 0 when the t is what? A constant. So that the momentum of the system remains what it is? Constant. Okay. This is the illustrations of your or the proof of your what law of conservation of linear momentum. So that can be illustrated in a single particle. That can be what illustrated in a single particle. Next, let us discuss how that linear momentum remains constant in case of what a single particle. For that, you are having what it is. There, the mass of that particle is m1 and its velocity is v1. So again, that p equals to m1 into v1. When you differentiate that quantity, so you are getting what it is. dt by dt is equals to m1 into dv1 divided by dt. So where dv1 divided by dt is nothing but your what? ACM. Then m into ACM is nothing but your what? External, F force. Here, external force acting on that system is 0. Then you are getting what? F is equals to 0. When your f equals to 0, then dp by dt equals you are getting what? 0. Therefore, p is equals to what? Constant. The total momentum of the system remains what? A constant. Okay. So sorry for the disturbance. The same things can be what explained in two particles, or if the system contains what any number of particles. Suppose if your system contains an what n number of particles, in such cases, see here. So what I have written is P is equals to P1 plus P2. P is equals to what? P1 plus P2. P is equals to P1 plus P2 plus P3. So on up to what? Pn. That means so you are having n number of particles. Okay. So therefore, dp by dt is equals to dp1 by dt plus dp2 by dt plus of dp3 by dt up to what? dpn divided by dt up to what? N number of particles. Okay. So that's why we're getting f is equals to f1 plus f2 plus f3 and so on up to what? Fn. Here, dp by dt is nothing but an f external. So here you are having no external force acting on that system. When it becomes f external is 0, then dp by dt is equal to what? It is 0. So that p becomes what it is? Constant. But here p becomes when that p is constant, then dp by dt is equal to what is 0. This is the illustration of your what? Law of conservation of linear momentum. What it is in the absence of any external force acting on that system, the total linear momentum of that system remains what it is a constant. Okay. Next, let us discuss about the center of mass. What it is? Center of mass. When the system contains a large number of many number of particles, in such cases, it is difficult to specify the motion of what individual particles. In this time, so we are considering what a center of mass of that system. What it is? Whenever you are having a large number of particles, in such cases, it is difficult to specify the motion of individual particles. Therefore, during this time, what we're doing is we are considering the center of mass of that system of particles. Okay, so here, whatever the diagram is there, so this system contains what? Two particles, m1 and what? m2, and r1 and r2 are the positional vector of these two particles. R1 and R2 are what? The positional vector of these two particles from the fixed point, from the fixed reference point, from what point you are going to what? Measure all these things. Where the capital RCM is the positional vector of this what? Center of mass of the system. The CM is nothing but center of mass of these two, your system of particles. Okay. So therefore, uh, the the positional vector of this center of system is given by RCM is equals to M1 R1 plus of what? M2 R2 divided by M1 plus M2. This is for what? The system consisting of a what? Only two parts. Suppose if a system contains what? N number of particles, there that position vector of that center of mass of the system becomes what? RCM is equal to M1 R1 plus M2 R2 plus of what? M3 R3 and so on up to what? Mn Rn divided by M1 plus M2 up to what? Mn top. So therefore, in general, that's this is the what the expression for your positional vector of your what of the particles of the system. The positional vector of your system is. Suppose if that in general, if the system contains what n number of particles, in such cases, whatever rating is m into RCM. So that's total mass m1 plus m2 obtain what mn is what designated by what capital M. The total mass of that system is given by what capital M, and the RCM is the what the positional vector of this center of mass of the system. So therefore, RCM is equals to summation of what is k equals to 1 to n what yn mk into vk divided by capital M. So for your two particles, for the system of what two particles, that RCM becomes M1 R1 plus M2 R2 divided by what capital M. Capital M is nothing but what the total mass of that your what of whole system. Okay, so this is the expression for the positional vector of your what system of particles. Okay, next the same thing. Once you know that positional vector, you can write what is the velocity of that system or what is the velocity of that particle as well as what acceleration of what that particle that you can what write it. So here, the velocity is nothing but what is the rate of change of it is what it is displacement is called as velocity. So therefore, so when you differentiate that RCM with respect to t, you are getting dRCM divided by dt. The change in displacement with respect to time that is what velocity. That's fine. So I have written what v of cm is equals to summation of k1 summation of mn into vn k equals to 1 to n what n. So that's whole divided by what is capital M. Okay, this is what summation of k equals to 1 to n what n mn into vn, where that mn and when k equals to 1, you are getting m1 and vn. That means you are getting the velocity of what first particles, velocity of center of your what first particles in the your systems. Okay, the same thing when you differentiate this above quantity with respect to t, you are getting what accelerations. So dvcm divided by dt is nothing but what accelerations. When you make it a cross multiplication, you are getting f external. F external is equals to d by dt. We know that summation of k equals to 1 to n dpk. Sorry, this pk. So mk vk is equals to capital M into vcm. And here I'm differentiating this one. You are getting this quantity. So here m into vk is that we take it outside. Capital M is outside. We're getting f external is equals to capital M into dvcm divided by dt. Here dvcm divided by is nothing but our what accelerations. So that f external equals to what m into acm. So here acm is equals to f external divided by what capital. This is the what the acceleration of your center of mass of that system. Okay. In this chapters, so what we discussed is we have discussed regarding the law of conservation of linear momentum and the illustration, the proof of the law of that conservation of linear momentum in single particle, in two particle, and what the system of particles, the system consisting of what n number of particles. Okay, we'll stop at this stage. The remaining thing will be discussed in the next class. Thank you. Hmm.